Hey geometry friends, we are going to do a very quick pair of theorems today that just involve proportions, just like yesterday's lesson did. So try not to get overwhelmed because it's really not that bad. Today we're going to talk about the angle bisector theorem. And the angle bisector theorem says this: if you have a triangle, okay, like we have right here, and you bisect one of the angles, when you bisect that angle, the two values on one side and the two values on the other are proportional. That's it. And I want you to circle it just like I'm doing it because it's a good visual reminder of what you're supposed to do. All right, so when you bisect an angle, the side and the piece below it end up being proportional with the other side and the piece below that. Let me show you what I mean. So if we come over here to this triangle right here, and I know this is 18 and that's 24, and this is 12 and this is x. 18 over 12 equals 24 over x. That's it. Seriously, you just set that up and then you solve it. So let's try to do that. I would have 18x equals 12 times 24, which is probably 288, and it is, equals 288. And then if I divide by 18, divided by 18, I get 16. Done. There's my answer. Look at this. This is another angle bisector, and I know because it has those little arc markings. When you have an angle bisector, the side and that part of the base is proportional to the other side with that part of the base. 15 over -1 plus x equals 35 over 21. Cross multiply again. 15 times 21 is 315. Equals 35 times -1 plus x. Let me distribute. Add 35 to both sides. $350. Divide by 35. And I get x equals 10. Done. Three sides of a triangle are 8, 12, and 15. An angle bisector meets the side length of 15. Find the lengths of x and y. Now, this is more realistically how you would be using this. You would normally know the three side lengths of the triangle, but you just don't know how they get split up. So, if I have an angle bisector, I know 8 over x equals 12 over y. By the way, if you wanted to, you could set that up as x over 8 equals y over 12. That is also equivalent. Okay, but that's too many variables. I got too much stuff. But what I also know that if this entire side is 15, that means x plus y equals 15. There we go. Which means y is 15 minus x. I can do substitution. So I'm going to come over here and erase my y and write 15 minus x instead. So I have 8 times 15 minus x equals x times 12, so 12x. I'm going to distribute my 8 here. 8 times 15, whoops, that's not how we do that. 8 times 15 is 120 minus 8x equals 12x. I'll add 8x to both sides. 120 equals 20x. Divide by 20 and get x equals 6. Now the question says, find the lengths of x and y. Well, if x equals 6 and that whole side was 15, y is 9. That's the angle bisector theorem. You bisect an angle, you create a proportion every single time. Next, now we've got the side splitter theorem. This is just another way that triangles can split to make proportions. If you have a triangle, and inside that triangle you draw any parallel line to a side, in this case it's usually the base, it splits the top and the bottom, that should say D, it splits the top and the bottom proportionally. A over B equals C over D. Every time. Okay? So let's do it. Here's a triangle. These are parallel. Whenever you have a parallel line, A over B equals C over D. The top part over the bottom part equals the top part over the bottom part. Well, 5 divided by 5 equals 7 divided by 1. 5 fifths is 1. That would mean x is 7, because I'd have to have 7 sevenths on the other side. All right, same thing over here. I've got a parallel line. So top to bottom equals top to, well, if this whole thing is 33 and the top's 11, the bottom's 22. Okay, so in this one, I can't do a real nice shortcut, so I'm going to cross multiply. 22x equals 11 times x plus 12. And I want to show you something fun here. You can distribute this 11, or you can divide it. I'm going to divide by 11 instead of distributing the 11. And 22 divided by 11 is 2. So now I have 2x equals x plus 12. And then if I subtract the x, I have my answer. X equals 12. Okay, example 6. Well, I've got this line in here. Ooh, I forgot to tell you. KL is parallel to JH. That is an oversight on my part. So pretend I told you that KL is parallel to JH. Well, if I have a parallel line, top over bottom equals top over bottom. So y over 11 equals, oh, wait a second. I don't know the top and the bottom. All I've got is this 14 and this 24. You cannot use the side splitter theorem unless you are working with the split sides. It is called the side splitter theorem because it only applies to the split sides. It does not apply to the bases. Okay, so how is this different? We're using the bases. Which means that example 6 has really little to do with the side splitter theorem, but it can still be solved because if I know that this is parallel to that, then these angles would be corresponding and congruent, as would those, and so I have similar triangles on the top and the bottom. So if I work with similar triangles here, the left-hand side of the top triangle is y, the bottom of the top triangle is 14. The left-hand side of the whole triangle is y plus 11, and the bottom of the whole triangle is 24. So I did y to 14 equals y plus 11 to 24. No side splitter theorem, similarity proportions. Okay, and now I want to solve. So I have 24y equals 14 times y plus 11. Now, I could divide by this 14 right now, but 24 isn't divisible by 14, so I'm not going to do that. I'm going to distribute. 14y plus, what's 14 times 11? That's going to be 154. Subtract 14y. I'd get 10y equals 154. And then if I divide by 10, I get y equals, let's see, 15.4. Okay. And then last part, a corollary to the side splitter theorem is it doesn't have to be in a triangle. Okay. It could be in a quadrilateral. It could be in parallel lines like this. What we've got in this one is if you have parallel lines that are split by another parallel line, top over bottom equals top over bottom. 2 over 8 equals x over 12. Well, 2/8 is 1/4. How many twelfths would be a fourth? That would be 3/12. So x is 3. I'm done. Okay, what are the big ideas? They're in the box. The side splitter theorem says top piece over bottom piece equals top piece over bottom piece. The angle bisector theorem says if you bisect an angle in the triangle, the side compared to the bottom is equal to the side compared to the bottom. That's it. Hopefully that makes sense. Go and do your homework. Bye.